Hey guys, welcome to my channel. My name is Rashmi Devangan and today we're going to discuss about the use of air traffic service surveillance system. Also, if you want to see other videos on the topics of air regulation, you can see it on my channel. So let's get started. So to start with, the ATS surveillance system is used for identification of the aircraft within the airspace. So ADS-B is an automatic dependent surveillance broadcast. PSR is a primary surveillance radar and SSR is the secondary surveillance radar. And there are many more which we'll be discussing about in the chapter later on. So first I'll give you a brief overview of what ADS-B is. ADS-B is having the same application like the PSR or SSR, and it allows the ATC to automatically or repeatedly access data from all the equipped aircraft and use it or rebroadcast it to other aircraft within the range. Okay, so what it does, it automatically and repeatedly takes the information from the aircraft and either they use it for their identification, positioning, etc., or they rebroadcast it to some other aircraft which may require the information of that aircraft. Okay, and PSR is a primary secondary radar, as I told you. So they are used in circumstances where the ATS surveillance system cannot work alone because they are not able to fulfill the requirements of the air traffic services. Okay, SSR systems, especially those utilizing the monopulse technique or having mode S capability. Okay, so this is given a little bit detail that mode S capability is there, or MLAT. Then in that case, the separation between the aircraft is provided by the SSR system, provided that there are two conditions that the SSR transponders are mandatory in the area. So in this case, in SSR actually, transponder and interrogator, these pairs are there. So the interrogator is in the ground and the transponder is equipped in the aircraft. So if any aircraft who is not having a transponder, then they cannot perform this SSR surveillance system. Okay, so that is a mandatory thing, and then identification is established and maintained. So they have to be identified beforehand. So this was about the SSR and PSR. We discussed about ADS-B. ADS-C. So ADS-C, in this case, C stands for contract. So what it does is its uses are the same as that of this ADS-B only, but the thing is that it is on board the aircraft and again automatically transmits the similar information only to one or more specified ATSUs or the AOC. AOC stands for Aeronautical Operational Center. So that made a very pretty clear picture of the difference between ADS-C and ADS-B. Broadcast and contract, the name only suggests the difference between them. Right, now we'll be moving on to the advantages of ADS-B. So the advantages are like they are environmentally friendly technologies because they enhance the safety and efficiency and directly benefits the pilot, etc., because they use the satellite signals and for tracking the aircrafts. Okay, and also it makes it easy for the pilot because in their cockpit only this thing makes it very much easy to see the other traffic or the weather and terrain nearby. So all these things are made available to the pilot. Okay, and then next thing is it gives indication and alerts of the potential collision and it has greater coverage. So this is the advantage of the ADS-B. Moving on to MLAT. MLAT stands for multilateration. So it is a technology to accurately locate the aircraft using the time difference of arrival, which is also known as TDAO short form. So what it does is that it employs a number of ground stations which are placed in the strategic locations around an airport. It does not require additional avionic equipments as it uses replies from the mode A, C and S transponder as well as military IFF and ADS-B transponders. So in this case, what happens is that the aircrafts will be in different distances from the aerodrome, and similarly the according to their distances, they'll be receiving the signals, and similarly they'll be replying it, and the reply that they are giving, that will be received to the aerodrome within a difference of fraction of seconds. So this fraction of seconds is only used to calculate the position of the aircraft. Okay, so this is how MLAT works. We'll be moving on to the next part now, which is the radar applications. So radar applications have actually made it very much easy to for the identification of the aircraft and positioning of the aircraft in the sky, right? So they have been very helpful to reduce the minimum separation between the aircrafts, and since we are able to reduce the minimum separation between two aircrafts, then we can do maximum utilization of the airspace sky that is available. Okay, so these are major two very much positive points of using a radar in our surveillance system. Next important point is that radar vector will always give you a magnetic heading, not a true heading, compass heading, nothing. It will give you a magnetic heading, right? Next is, actually the radar control service is something which will be providing the aircraft operating within the control airspace. Okay, so this will be the service, radar control service, which will be provided for all the aircrafts operating within the controlled airspace. Radar advisory service will be provided for the class F airspace aircrafts. Okay, and the final one, radar flight information service for identification in any part of the FIR. So this is self-explanatory that the control service is an important one. Radar control service will be provided in the controlled airspace. Advisory is the one which is given in a very, not a detailed one. So the advices are, it's not very detailed, as I already told. It does not tell you exact things. They just tell you that yeah, you have to go contact this person, that person. So they'll basically be giving you advices. So advices are given in class F airspace, as you already know that class A is the more strict airspace. Class F is quite lenient if you compare. And then finally the flight information service, radar flight information service. This is provided to the for identification of the aircraft in any part of the FIR. Okay, this is self-explanatory. Now, one more point, that two-way communication is required in this. Okay. What are the uses of ATS surveillance system? We'll be looking into three, four points here. So first point is that to provide the radar service. Okay, radar service, what all is included in this? To improve the airspace utilization. How is it done? By reducing the separation minima, right? Next is reducing the delays. Obviously delay has to be reduced, and enhance safety. Okay. Next point is that provide radar vectoring. So radar vectoring is actually used to assist pilot in their navigation, and also aircrafts are assisted for the purpose of resolving any potential conflict. They will also manage manage the traffic in such a manner that efficient departure flow or during the cruise or climb state is there, and also in the approach sequence also they will be managing all those things, right? So this is another work. Next is to provide the separation and maintain normal flow when the aircraft is experiencing communication failure within the area of the ATS surveillance service coverage, right? In case of communication failure. And also finally monitor the progress of the air traffic to obtain improved position information, and also any supplementary information regarding the traffic, and also significant deviation of the aircraft from the assigned routines. I know I have not written all of these in this, but these are actually very common things, so I'll list it out again. it will be providing you normal radar services. Radar services will include that proper utilization of the airspace by reducing the minimas, separation minima, and they will be used for safety of the air traffic in the airspace. First point. Second point was for vectoring the aircrafts, right, for helping them in navigation during cruise, climb, and descent phase also. And if okay, this was one point. Third point was, if the aircraft is experiencing a communication failure, in that case they will be providing certain separation or any other normal flow. If they have to carry on, they'll be suggesting them with the help of this radar instruments only. And finally, the last point was to monitor the progress of the air traffic. So if any deviation in the actual path of the aircraft is there, that will be noted down. Any supplementary information, if it is given by the aircraft, for example weather information, that will be noted down, and the information regarding the aircraft under control, any information, etc. Right? So that was the ATS surveillance system. Then finally, as I already told you about the controls, approach control and the aerodrome control service. So what will be happening in the approach control service is that they will be telling you the approach sequence, vector of the aircraft to position for the pilot, all those things, right? And the aerodrome control, as the name suggests, it will be used for managing the traffic in the aerodrome area, right? Next point is position indication. So position indication may be displayed as first is given as individual position symbol. Second is PSR blips and SSR responses. So what are these things? These are certain signals which are used to identify the aircrafts about the position and what aircraft they are in the airspace, because there's a lot of traffic and their identification is important. So these are helpful. If you are working in the PSR, then PSR blips will be there. SSR responses, you can respond to the SSR with the help of a SSR equipment, and individual position symbol. So this is, for example, PSR, SSR, ADS-B, MLAT symbols, or the combined symbols also. These are also used for the position indication, right? Now, the use of SSR without primary radar. In case of aircraft transponder failure, the aircraft is normally permitted to continue to operate to the next landing point. A request is in flight plan is necessary if the aircraft takes off knowing transponder isn't working. Okay, if the SSR is used without the primary radar, then if the pilot already knows that the transponder is not working and still he takes off, that means he has already requested about this in the flight plan. And if in the mid-air, somewhere in the higher flight levels he is flying, he has already taken off from some airport long time back, and in between the flight he finds out that the transponder is not working, in that case he'll continue to operate to the next landing point. Okay, so coming to the ATS surveillance service identification, radar identification to be made in prior by one of the methods in Doc 4444 PANS ATM. So before the ATS surveillance service is provided to the aircraft, the radar shall identify the aircraft by any of the method which is given in this document. Alright, and if the identification is lost, then the pilot shall be informed accordingly and the instructions will be issued so as to restore non-ATS surveillance service preparation. Okay, moving on. Now, ADS-B identification procedures, by any of these three methods they have to give the identification of the aircraft by the ADS-B label or transfer of the ADS-B identification or observation of compliance with an instruction to transmit the ADSB ident. Similarly, if you are using an SSR or MLAT identification, SSR or MLAT, then in that case, how will you identify? It's the same. SSR or MLAT label again assign discrete code. So any discrete code may have been assigned, the setting of which has been verified in SSR or MLAT label. So that thing. Then mode S equipped aircraft in SSR or MLAT label. So direct recognition of the aircraft identification is done if mode S equipped aircraft in SSR or MLAT label is there. Okay. Then transfer of identification again. And then observation of compliance with an instruction to set any specific code or maybe a squawk ident. Okay. So if you are using PSR, then how to identify? In this, we'll be talking about three different circumstances. Position report if you are at some position, departing aircraft method, and turn method. So first, position report method. In this, a correlation is drawn between the radar position indication and the aircraft reporting position. If they both are consistent, then it is identified. Secondly, it is again the same for the departing aircraft, that the correlation is drawn between the radar position indication and the aircraft flight path. And also that the identification has to be established within 1 nautical miles from the end of the runway used. Okay, so that is one thing. And then finally the turn method. In this method, the aircraft is actually asked to execute one or more changes in its heading, maybe for greater than 30 degrees or more. And then again the instructions which are given to it and the radar position what are indicated, they are again matched. So if that matches, then the turn method, then within this method the PSR identification is confirmed. Now we'll be coming to separation minima. Separation minima is only applicable between the identified flights, and until and unless the identification is maintained, it has to be maintained, the minima has to be maintained, right? And this is not applicable if the ATS surveillance service is failed. So in this case, a procedural separation minima will be applied if the ATS surveillance service fails, and if the ATS surveillance service coverage has you have got out of that coverage area, or to the aircraft having ATS surveillance service coverage or entering adjacent FIR except where the ATS surveillance service transfer is effected. Then here it's given that based on the ATS surveillance system of ICAO, 5 nautical mile separation minima has to be maintained. And then there are also some points that 3 nautical mile can be maintained when the radar or the ADS-B or MLAT capabilities permit, and 2.5 nautical miles between the succeeding aircraft which are established on the same final approach track within 10 nautical miles of the runway end threshold. So 2.5 nautical miles can be applied in that case, separation. So a reduced separation minimum of 2.5 nautical miles may be applied provided the local factors are also permitting you of such reduction. So that is the case here. Finally, the wake turbulence radar. This is already a very common thing again, that the wake turbulence is dependent upon the size of the aircraft. So if it's a big aircraft, then the wake turbulence is severe. So you have to maintain a larger distance from the preceding aircraft. Otherwise, you'll get into the wake turbulence of that aircraft, and your aircraft will become uncontrollable. So that is only the thing about the wake turbulence. And then the speed control procedures. So if you are flying below 1000, I'm sorry, I have written 1000 here. It is not 1000, it is 10,000 feet. Okay, it is 10,000 feet. If you're flying below 10,000 feet, then your speed should be 250 knots, not more than that, and this speed is indicated airspeed. And if you're below 10,000 feet again, but 15 nautical miles, within 15 nautical miles of the VOR DME, that means the airport, then 220 nautical mile per hour should be your speed. Again, that is an IAS. So that was about the speed. So when is this terminated? The ATS surveillance service, when does it end? It automatically ends if the aircraft is receiving an ATS surveillance service saying that you have to contact the tower frequency now. So no need to continue with the ATS surveillance system. And also an aircraft which has been informed that it is provided with the ATS surveillance service should be informed immediately when for any reason ATS surveillance service is interrupted or terminated. So you have to inform that. Next we will be coming to procedures for operation of the SSR transponder codes. So in this case, so this is an important one, all the aircraft carrying the serviceable transponder shall operate the transponder all the time during the flight within all the FIRs in India. There are 6 FIRs in India, which are Chennai, Mumbai, Delhi, Kolkata and Guwahati. So if you're flying within any of the FIRs, in that case you have to operate the transponder which is there in your aircraft. Okay, now what are the operating procedures? So if the aircraft is departing from an aerodrome from India, okay, so it is saying that within the FIR of these, that means in anywhere in the Indian territory, in that case an appropriate SSR code on departure is assigned. SSR code is assigned on departure. Okay, this SSR code setting shall continue unless instructed otherwise. Then for the international flight entering any of these FIRs shall continue to maintain the SSR code being squawked in the adjacent FIR. And the aircraft engaged in the domestic flight shall operate the transponder on the last assigned code. Aircraft not assigned an SSR code shall operate transponder on the mode A3 code 2000 before entry into any of these FIRs and maintain that code until and otherwise instructed. So if it is not given to you, then 2000 has to be your SSR code. It's written here. Okay. And last point is that the transponder not operated on the ground except for the time when entering runway or vacating runway to avoid interference. So in order to avoid interference or radar display, on the radar display, the pilot shall not operate this transponder. Okay, where? In the runway, while if you are either vacating or you are departing from the runway. So the last and final topic, verification of accuracy of mode C derived level information, ADS-B altitude data transmission. In this case, tolerance of the pressure altitude level information displayed is plus minus 200 feet in the RVSM. What is RVSM? Reduced visual separation minima, reduced vertical separation minima. It should be plus minus 200 feet and in other airspace plus minus 300 feet. Then report the level altitude on the first contact with the radar to facilitate verification of mode C altitude information and verification of accuracy of the SSR derived altitude should be done. So verification has to be done, and it normally says that you have to tell your altitude in the first contact with the radar to facilitate verification on mode C altitude information. Okay, so that was it all about it. Okay, yeah, one more point, that if following the confirmation of the level and correct pressure setting, the discrepancy continue to exist, the controller may request the pilot to stop the mode C transmission, and he may use the phraseology that stop squawk Charlie, wrong indication, or stop ADS B altitude data transmission. This is what he'll be telling if you are saying that some wrong altitude or flight level. In that case, you'll be asked to recheck your flight level, or pilot is asked to check his pressure settings and confirm his level. This was the end of the video. I hope you liked it, and if you did, do give it a thumbs up, and also subscribe to my channel if you haven't subscribed it yet. Thank you so much for watching. We'll see you in the next video.